Okay. So whenever any new user is creating an account, they provide their username. Let's say I'm giving my username as Rohan and my password is admin123. Now, if you will store this information in plain text inside the database of the firewall, right? Then if hacker is going to gain the access of this database, they will be able to see your username and password. And it might be possible, this is normal human behavior, that we use same username and password on multiple websites. So what hackers, how they steal your information? They try to exploit the, weak websites. They try to steal the information there. You must have seen in the news that data breach, data has been leaked. So what they do, they try to steal this information from the databases and then they sell this information over dark web so that any random user or any company, they can use these details to gain, to perform any illegal task or anything, any illegal credit card transaction, unauthorized login to your accounts, whatever it is, right? So now whosoever is building the website, it is their utmost responsibility not to save these credentials in the plain text inside their databases. So what we do, whenever you create any user account on our website, when you're supplying the password, we never save the password in the plain text. We generate the hash. So MD5 is very weak these days. We don't use it anymore, right? So I'm just taking an example. So MD5 algorithm is used to generate the hash. Now, when this admin123 will be given to this particular hash generator, it will generate a unique value. Let's say it has generated this AQEIO 5, 6, 7, 8, 9, 10, whatever it is, a long hash value. Now, this value I will be storing inside my database. Now, whenever you are logged in, you will provide your username and password only, the password which you have used to create the account. That password will be again processed by the hash generator. It will generate the hash and that hash value will be matched inside the database. If it is matching, then only you will be able to log in into my website. Otherwise, you will get an error password didn't match or invalid password, invalid username or password. So in the same way, Palo Alto is taking the 6 tuple values, generating the hash out of it, and then storing it inside the database. I told you this before as well. These firewalls are vulnerable for multiple attacks. If you are storing the user information of your network user information on the firewall locally, let's say I have this firewall and I have created local user database on the firewall. I mean, whatever users are present inside my infrastructure, I'm storing their information locally on the firewall. Now just imagine if this firewall gets hacked, hacker will steal the user details from the firewall itself. And then it will become really easy for the hacker to navigate inside your infrastructure. So same story applies here. Whenever we store any information in the databases, we need to ensure that it should not be stored in a plain text. It should be always in hash format. Okay, this is the best practice to save any credential related thing in this inside the database. I hope now it is clear.
Yes, sir, it's very clear. Thank you very much.
Yeah. And another reason behind taking hash values, it's like when you do search in your database, it becomes really easy. I'll explain you. It becomes really easy to perform the search. Let's take an example inside your database. See, because you're studying this firewall, this is the next generation firewall. You need to ensure that you understand these terminologies: database, web server, because the firewall which you are studying, it has everything inside it. Web server is there, database is there, right? Different engines are there. So I'll try to explain everything in more details in upcoming lectures. So, inside your database, let's say you have 1,000 entries. Let's say we have 1,000 flow keys for 500 sessions. You have 500 sessions. Each session is having two flow keys. So you will have 1,000 flow keys inside your database. Now just imagine if I need to do a search basis on source IP, source port, destination IP, destination port, protocol, and my ingress zone, or you can say the source zone. The algorithm which I will be using to do the search inside my database will be recursive. I need to check each entry one by one and need to match, first I'll check first entry, what is the source IP? Oh, this is the source IP. Okay, it is matching this. Then I will check what is the source port. It is matching to the first entry. Okay. If not, then I'll check the second entry. So now just imagine the number of permutation and combinations this firewall is going to take in deciding whether this packet belongs to any existing session or not. This will degrade the performance of this particular box. So how can you improve the performance? Let's take an example that these six tuple, let's denote them with a particular numerical number, and we are calling it hash. And let's say the hash of this particular information is turning out to be 1, 2, 3, 4, 5. This is the hash value. And this value you are storing inside your database. Now, when you're doing the search inside the database to identify the session ID, it will become really easy to identify this particular value instead of doing search basis on these six inputs. So this will drastically decrease the number of permutations and combinations. Make sense now?
Yes, sir, it makes sense. And thank you for detailed explanation.
Okay. Yeah, Vikas, please tell me.
सर मुझे ये पूछना है कि कल आपने बताया था कि जो फर्स्ट टाइम जो सिक्योरिटी रूल चेक होता है तो उसमें प्री नेट आईपी एड्रेस और पोस्ट नेट जोन चेक होंगे, एप्लीकेशन नहीं रहेगा, ठीक है सर? तो उसमें कैसे सेशन, मतलब अगर मान लीजिए कोई एप्लीकेशन में ब्लॉक है वो चीज़, तब भी अलाउड तो हो ही जाएगा क्योंकि एप्लीकेशन तो चेक नहीं हो रही है। तो और टीसीपी सिन में तो कुछ एप्लीकेशन होता नहीं, तो सिन तो अलाउड हो ही जाएगा ना सर फिर?
No, you didn't understand this condition properly. You can see my screen, right? Security policy lookup.
Yes, sir.
So these are the three match criterias. So yesterday I was giving an example that you have 1,000 rules, security rules. How PAN-OS will ensure that efficiently we should be able to hit the correct rule out of these 1,000 rules without evaluating each rule for this particular packet. How we are going to do that? With the help of these criterias. So first criteria says, I will use your pre-net IPs, post-net zones to search the rule where application is set to any and URL category is set to any. Right? This is my first criteria to search for any rule. If you are creating the application based rules or URL based rule, then second criteria will take hit, where it says it will skip any rule with action not set to allow if the application or URL category causes the match. तो इन शॉर्ट हिंदी में भी एक बार बता देता हूँ. व्हाट डज इट मीन कि पहले वाले रूल ने बोला कि मैं चेक करूंगा प्री नेट आईपीज पोस्ट नेट जोन्स, ये अगर मेरे रूल में डिफाइंड है और एप्लीकेशन एनी सेलेक्ट हुआ है, यूआरएल कैटेगरी एनी सेलेक्ट हुआ है, तो उसके बेसिस पे मैं रूल को ढूंढने का ट्राई करूंगा. अगर मेरे को नहीं मिला फिर मैं दूसरा क्राइटेरिया चेक करूंगा कि मैंने एप्लीकेशन और यूआरएल के बेसिस पे एक मैच आइडेंटिफाई करा कि पहले वाले क्राइटेरिया के बेसिस पे तो कुछ नहीं मिला मेरे को 1000 रूल्स में से, दूसरे वाले क्राइटेरिया के बेसिस पे मेरे को एक रूल मिला है जिसमें एप्लीकेशन मैच हो रही है या फिर यूआरएल कैटेगरी मैच हो रही है. अगर उसका एक्शन अलाउ नहीं है तो मैं वो वाले रूल्स स्किप कर दूंगा, अगर अलाउ होगा तो ही वो रूल हिट लेगा. और अगर ये
ठीक है।
दोनों
हाँ सर,
क्राइटेरिया बाईपास हो गए देन इट विल फॉल बैक टू द थर्ड क्राइटेरिया व्हिच सेज दैट इट विल हिट द डिफॉल्ट रूल्स,
ठीक है
एनी
सर।
वन
मान
ऑफ
लीजिए
देम.
पहले, सर मैं ये कहना चाह रहा हूँ, मान लीजिए पहले वाले क्राइटेरिया में मैच हो गया, मिल गया आपको, ठीक है सर, और अगर आगे एप्लीकेशन में भी वो है, वो एप्लीकेशन भी हमने ब्लॉक किया है, लेकिन क्योंकि वो पहले क्राइटेरिया में ही मैच हो गया है, तो नेक्स्ट
तो
तो
वो
चेक होगा नहीं,
हिट लेके निकल जाएगा बाहर. तभी तो मैं
निकल
वी हैव
जाएगा।
टू कीप अवर, दैट्स द रीजन वी हैव टू कीप अवर रूल्स वेरी स्पेसिफिक. See, I'll tell you the the proper way, or you can say the industry best practices to define your rules. This is the problem because you have not done the implementation on your own, or you have not designed the network on your own. So the guys who are working in support roles, they don't understand what should be the proper order of defining the security rules in any given firewall, right? So what industry says, your more specific rules should be at top. More specific means where you have defined the user source IP, source port, destination IP, destination port, everything, application, URL categories. So your more specific rules should be at top. And your least specific rules means where you have kept things very loose, any sort of configuration. You should keep them at the bottom so that these specific rules should always take hit. So what we do when we do project deployment, I'll tell you, whenever you are migrating any particular site from legacy firewall to the next generation firewall, what should be your approach, or how the technical design authority TDA will ensure that the implementer who is implementing the solution should not mess up anything. So what we do, first we create many specific rules. We give them the script that guys, this is what you need to do. Create rule number 1. This is for LAN users. Source IP this, source port this, destination IP is this, destination port is this, right? Protocol TCP. Rule name is whatever web server or internal web server if they wanna access. Rule number 1. Then similarly, any database server. So I'll create another rule for that. So I'll keep on creating these specific rules and I'll enable the logging. And at last, before default rules, I will create one loose rule. Let's say at 100th position, I have created another rule, which is like allow IP any. And I will enable logging on this rule to understand that after creating all these security rules, still we have a traffic which is hitting this particular rule, right? And once we will check the logs that what type of traffic is hitting this particular rule, we will then create more specific rules so that that particular traffic should not hit this rule. And once this fine tuning is done, right? Once we do the fine tuning of the security policy, then we remove this rule from the firewall. Because now firewall means that all the ports and services will be blocked by default. If you want to open up any communication, you should have security rule for that. Otherwise, the communication should be blocked. So as per the best practice, if you go with ZTNA, Zero Trust Network Access, the framework, it will say that keep your network as much as segmented you can. Do not keep your network flat. Flat means you don't have any segmentation at your network level. Everyone can talk to anyone, right? So these are the things which are industry best practices. When you will discuss these things with the TDAs or the architects, they will tell you that what approach they follow and why they always have this cleanup rule, or you can say this allow IP any rule. You must have seen in your firewalls as well. Whenever any new site has been handed over to you guys in support, you must have seen this particular IP any rule at last. And after some time, you must have got the customer request that now please remove this rule, because they have the fine tune the security policy. Similarly, we fine tune the IPS policy. In IPS, we have the antivirus profile, we have the vulnerability profile, right? We fine tune them basis on the signatures. So I'll try to cover all these things throughout my sessions so that you understand how industry works. Any doubt,
सर
anyone,
अगर
before I move?
सर एक डाउट हो रहा है सर, अगर एप्लीकेशन में कोई ट्रैफिक ब्लॉक है, एप्लीकेशन ब्लॉक है, वैसे अलाउड है मतलब, तो उसका सेशन बनेगा, सेशन टेबल में आएगा, वो दिखेगा हमें ये?
Obviously, because your three-way TCP three-way handshake will be done.
वैसे भी आपका ये वो तो रूल से ड्रॉप हो रहा है ना, आपका 3-way हैंडशेक होने के बाद ही तो रूल चेक कर रहा है।
Because
मतलब सर एप्लीकेशन
your drop
ब्लॉक
your
भी
drop
है?
wait
Yes, sir.
your drop is
Okay.
happening because of application ID. Okay.
Yes, sir.
So it means that three-way handshake has been done, because in SYN packet you don't have any data. It is normal SYN packet. In SYN plus acknowledgement, in acknowledgement, there is no data available inside these packets.
Yes, sir.
Okay.
ठीक है
Okay.
सर, मतलब सर अगर एप्लीकेशन में कुछ अगर ब्लॉक भी है तब भी टीसीपी हैंडशेक तो होगा, उसके बाद ही
Yes. Whatever layer 4, layer 7 information based actions you are taking, in those actions, you will see that always TCP three-way handshake will be done. So you will see the connection on the firewall.
So we can say whatever flow sequence is in flow, और वो जहाँ से ड्रॉप हो रहा है उससे ऊपर की सारी इंफॉर्मेशन वो चेक करेगा, राइट सर?
Yeah. Okay. I'll take your doubts after this session now. Let's not make this session as Q&A. Okay. So yesterday we have seen ingress processing. We have seen slow path setup for SYN packet. And now we will see the fast path processing for the SYN. And once completing this complete packet flow, then I'll quickly walk you through the SYNAC processing, acknowledgement processing, SSL handshake processing. And then we will also have a look on the detailed logs, basically the CPU dumps, which I will walk you through. So this packet flow session is going to run for, a couple of days this time. So it will be like 7 to 8 hours complete journey of Palo Alto packet flow. Why I'm doing this? If you are able to understand this particular packet flow, then none of the firewall will be challenging for you to understand, because core concepts will remain same, beat any next generation firewall. Okay. So yesterday we have seen that when we have received this in packet, so it was processed by the ingress processes. Then we did the flow lookup to identify whether there is an existing session for this or not, and we were not able to find any existing session. So the packet went inside the slow path. We performed these checks, and after creating and installing the session, again we came here to check the session state. Now flow session state in session table. If the session state is closing or closed, it will send back to the session setup, right? Since this is the first packet, we have just created the session. The state might be opening or active or discard. Discard will not be there because this is the first SYN packet. It could be opening or active. So if it is opening and active, it will go here. It will reset your session timeout value. Each session, each protocol inside the firewall has respective timeout values. Let's take an example. TCP will be there in your session table for 3600 seconds. It means 1 hour. If it is UDP, let's say it is 6 seconds. So accordingly for ICMP, let's say it is 2 seconds. So like this, we have defined the, you have the default timer values as well, and you can modify these values as well as per your convenience or as per your infrastructure. Okay. So if the state is opening or active, you're going to reset the timeout value. And if it is opening and active, then only you are going to enter inside the fast path. If it is discard, then your packet will be dropped. Now, when it is entering inside the security processing, or we call it fast path, so again here we will do the processing of your layer 2 till layer 4 information. So your layer 2 information MAC addresses, your layer 3 information IP addresses, and your layer 4 information, the port numbers. They will be processed again inside your security processing, or you can say the fast path. And we are going to apply the NAT, be it source NAT, destination NAT, or twice NAT, source and destination both, right? If any error occurs during this process, your packet will be dropped, right? If there is no error, then we will perform the forwarding lookup again for all client to server and server to client packets. And if there is no route or if there is zone change, then your packet will be discarded. Now, interviewer can ask you one thing, that why you guys are again doing the forwarding lookup in fast path, because we have already done it inside the slow path. So always remember, slow path is only there for SYN packet, for the first packet. The subsequent packets will directly come into the ingress stage, then they will go inside the flow lookup stage, and then they will enter the fast path. They will not go inside the slow path. Reason being that we have the existing session ID available. So if something is directly coming to the fast path, we need to check the routing, right? It might be possible that a connection was active for certain period of time, users were working, and the firewall administrator has accidentally deleted the route from the firewall. Some routing change has been done, or some zone change has been done. So if we will not have this particular check here, your existing connections will keep on working. So whatever dynamic changes you are making to your firewall should adopt or should adapt those dynamic changes in a fraction of seconds. So that's why we process this information again in the fast path. Okay. Now, after validating that you have the default route, this packet can go to the internet, or this packet can come from the internet towards our internal subnet. If that is allowed, then we check for SSL proxy. Okay. Now SSL proxy, here we will check whether this session has been flagged for SSL decryption. So right now this is SYN packet, right? It is not valid for SSL proxy. Firewall right now will not flag this session. So it will first come to this, then it will enter into this. We have the routing information, then it will check for SSL proxy. Since there is no data available inside the SYN packet, no IP datagram, it will directly go here. Application identified in this session. Again, SYN packet, no data bytes available. It will not go to the app ID. It will directly come down to this CTD flag enabled. Whether I need to perform layer 7 inspection on this. Again, no data is available. It will directly go to the egress stage. It will bypass your app identification. It will bypass your CTD deep inspection. It will directly go to your egress stage, where your packet forwarding processing unit will use the egress interface to forward this particular packet. It will apply the fragmentation if required. It will apply the QoS shaping if you have configured the QoS, and then it will check whether this egress interface is tunnel interface. If yes, then which particular tunnel we are using. It will encrypt, hash, encapsulate, and then send it back to this packet forwarding processing unit. And then all these steps will be repeated until this condition falls. And once this condition falls, the packet will go out from the firewall. Now, that is the only reason we place app ID cache, user ID cache in slow path. Now, you must have understood why I'm keeping app ID, user ID cache in slow path. Reason being that your SYN packet is not having data. It is not having layer 7 information inside it, right? It is having 0 bytes of data. So it will never enter inside app ID engine and your SP3 engine. So to make your firewall work efficiently, we should have a mechanism to identify the applications, user IDs without running the actual packet inside these respective engines. I hope I'm clear now. Now, see, we have seen the SYN packet processing. I'll show you the SYNAC processing acknowledgement. And when we will see the SSL packet processing, you will see the entire processing will change. That SSL first packet client hello will go inside the app ID. Then it will go inside the CTD and it will then come out through the egress state. So I will summarize the SYN packet processing, how it has been processed by the Palo Alto firewall. So what has happened?
Sorry to interrupt you. Can you just move to applications when application identification is not found?
I'll cover that. Just wait for that time. I'll cover that. So right now we have just seen SYN packet processing. So how it has been processed by the firewall? First, it has entered inside the ingress stage. Then it has entered inside flow lookup, where we have performed the lookup whether do we have any session for this particular packet, yes or no. We were not having any session for this because this is the first packet we have received from the client. It has gone inside slow path to create the session and install it inside the session table. Right after that, it has again come back to the flow lookup to check the session state, whether my session state is active, opening, discard, what is the state of my session. And then it has entered inside the fast path, security processing. Since this SYN packet was not having any datagram inside it, it has directly entered into the egress. It has bypassed app ID and CTD, or you can say SP3. These two tasks have been bypassed because SYN packet was not having data. Now, when your SYNAC will be coming from the server, again, it will follow the same thing. So when SYN plus acknowledgement packet is coming from the server, it will follow the same thing. Ingress stage, flow lookup, but this time it will not go inside the slow path. Reason being that in flow lookup, we will identify that this particular packet belongs to a session. So it will directly enter your fast path. And since it is also not having any data inside it, no app ID identification or CTD deep inspection will be done. It will directly enter inside the egress stage and it will be delivered to the client. Then your acknowledgement packet will come. So your acknowledgement packet, this is the last packet of TCP three-way handshake. It will follow the exact same thing which has been followed by SYN plus acknowledgement. Ingress stage, flow lookup, We will identify the session ID. It will go to fastpath. It will go to egress. Now you can see the processing. First packet has been processed by these many different stages. But second packet and third packet has been processed really quick. Now, when your SSL handshake will start after this TCP three-way handshake, so if I will go back here, so after establishing the TCP three-way handshake, your SSL handshake will begin. And the first packet you're going to get from the client, it will be client hello. Now this SSL protocol, it is a layer 7 protocol. Now your packets, whatever IP datagram you're sending over the wire, which are getting received by the firewall, will see datagram, data inputs, data bytes. So now processing will change. So we'll see the processing of client hello, right? This is the SSL. Before taking this, what I'll do, I'll consider the connection on port 80. I will show you without SSL how my processing is done, and with SSL how my processing is done. And then I'll tell you with SSL decryption how your processing will be done inside the Palo Alto firewall. Okay. So first, I'm taking the flow of normal website, port 80 website, and your connection formation will be like this. This is your client. This is firewall. We have this server, right? Client is sending this in. It has been processed by the firewall. Server has responded back with SYN plus acknowledgement. Then client has sent the acknowledgement. Your TCP three-way handshake is done. Now, since the client is connecting on port 80, there will be no SSL handshake. Right away, your client will send the HTTP GET request. Which is a layer 7 protocol, and it will have the data inside it. So once this packet will be received by the server, server will respond back with the HTTP response. And that information will be processed by your client, and you will be able to see a website inside your browser. Now this communication is happening in plain text. No encryption is there. So if anybody is doing eavesdropping, any hacker is sitting there and doing eavesdropping in between, they will be able to see what information is getting exchanged between the client and the server, right? So before going into that particular domain, let's stick to this HTTP processing and let's have a look how this packet will be processed as per our packet flow. Now, before I'll start this, if you have any doubt, just ask me. Then I'll show you the complete processing, how your application will be identified, and how your deep inspection will be performed inside the firewall. So yeah.
Yeah, it's regarding this layer 2 to layer 4 check in fastpath. Actually, we already have done this in ingress stage, but why should we do this again?
See, in ingress, you're extracting this information. You have not processed this information. There is a difference between extracting it and processing it. I'll explain you that, because many times I have heard this question. I'm not sure whether interviewers are asking this question frequently.
No, I was asked kind of multiple things like this.
See, what do you understand by term extract?
Extract means assembling, reassembling kind of.
No. Extract means you are taking out something. So you have received the IP datagram from which you are extracting the information. Layer 2, layer 3, layer 4. Why you have extracted this information? You are just copying the values, that what is the source IP, what is the source port, destination IP, destination port, right? Source MAC, destination MAC. You're just storing this information in some variables which will be further used to calculate the hash, to generate the flow key or to match the flow keys, to identify the sessions. This is the use of extraction process in the ingress stage. But when you are doing the processing means whatever values you have stored here, that this is the source IP, this is the source port, this is the destination IP, this is the destination port. These values might change when you're applying the NAT. So this is my source, this is my firewall, and it is going over internet. So if this connection is hitting the firewall, source IP is 192.168.1.0. Source port is 1234, right? When it is going to hit the firewall, you will do the source translation here, because then only your packets will go to the internet. So you need to change this IP address into the public IP address. So your source IP will change, your source port will change. It depends what type of NATing you are doing. One-to-one NAT, one-to-many. You are doing it from the pool, or you are doing PAT. So this information will change. If this information is going to change, it means there is a possibility these variable values will change. So that's why we need to do the processing, and we need to apply the NAT on that particular packet inside the fast
So in
path.
fast path, it will be applied right away, NAT and
Yeah,
PAT
right
policy.
away. Right away it will be implemented.
And all the checks like means in ingress stage we do this check like TTL value 0, then we discard this, and port is 0, we discard. So are these also checked here or not in fast path?
See, already you are entering inside the fast path once your flow lookup has been done. And
Okay.
these checks are part of your flow lookup. So
Flow
it will
lookup.
be done again and again.
Okay.
It is not available anywhere. I can understand your pain. This flow, this diagram is not available anywhere. It is not even
Yes.
mentioned in Palo Alto website, right?
Yeah, right. That's the issue. So just wanted to have full information.
Yeah. So now let's have a look on the HTTP processing, how my HTTP GET packet will be processed. So on Ethernet, one by one, my client is connected. And this is my egress interface through which my server is reachable. So TCP three-way handshake is done. Connection is on port 80. Plain website, no encryption, no SSL is involved. Now HTTP GET request, or you can see this GET packet IP datagram, will be received on this interface. Now it could be in single IP datagram, or it could be in fragments. I'm not sure whether you have done the last activity which I have told you, that connect to your home router web page, take the Wireshark captures, you will see the TCP stream, and then you will be able to see the HTTP packets as well. And you will understand how application works, for how any web application, mobile application, or online applications, these are working, right? And how your network devices are playing vital role in enhancing the user journey while accessing the application. Because whatever we are doing in enterprise network, we are doing it to enhance the user experience of the application access. Okay. So now your GET request is going to hit the Marvel chip. Then it will be forwarded to the network processor. Now this chip is there to take care of the offloaded session. Now this is another thing which is there in Palo Alto Firewall. I will talk it about this terminology later on. What is this offloading, right? So right now we'll keep it simple that my guest packet has hit the interface. It has been forwarded to the Marvel chip. Marvel chip has forwarded to the network processor. Network processor has forwarded to the DP-CPU. Now DP-CPU will start the processing as per our packet flow. This is the packet journey from hardware to software. Now my packet flow says that first thing what I will do, I will check the initial processing inside my ingress stage. I will extract the L2, L3 information. I'll check for the parsing errors. I will check for the DOS table. I'll check whether firewall inspection is applicable or not. I'll check whether tunnel packet, this belongs to any tunneling or not. If not, then I'll go inside the flow lookup. So I've done the ingress processing for this packet. Then it will enter inside the flow lookup. Now this time we have a session for this particular packet. So when we will do a lookup for this flow key, we will be able to identify the session ID. And once you get the session ID, then you will directly come here and you will enter this particular check whether what is the session state inside the session table. Is it opening, active, discard, free, closing, closed? If it is opening, active or discard, then only I will go here. If it is closing or closed, so I will enter the slow path again. Or if it is free, then I will discard the packet. So we will talk about these states as well. What are these states and how vital these states to take this decision. So right now I'm considering that my session state is active. So then the timeout value will be reset and it will enter the fast path directly. So how I'm doing the processing for this HTTP packet? First, ingress stage processing has been done, then flow lookup, and then fast path. Now, when it is coming inside the fast path, I will apply the NAT, I'll do the layer 2, layer 4 processing. Now I will check whether SSL proxy is flagged for this session or not. If not, I will check whether application has been identified for this session or not. This time, if my answer is no, I will enter my packet inside the app ID engine because this HTTP GET request is nothing but a layer 7 protocol. For firewall, this is a data. So now your packet will enter inside the app identification. So now let's have a look how it will be processed inside app identification. Another thing, you guys are getting confused because you must have seen multiple videos over internet regarding SP3 engine, or you must have got this input from your colleagues, from your peers or the trainers that Palo Alto does parallel processing. Everything is processed parallelly, right? You just send the packet and it is going to do the going to identify the app ID, content ID, threat ID at one pass. That is not the case. It will be done sequentially only, right? We do have multiple cores available. We do have multi programming or multi processing available, but there is a way of doing it, and that's how it is done. This is the complete picture how your Palo Alto firewall is doing the processing. Okay. So now when your packet enters into the application identification engine, the first thing which I'm going to check is, do we have any application override policy match? Now, what is this application override policy match? So if you want to bypass app identification from the firewall, you place that particular application in your override policy. Why we are doing it? Reason being that when the packet is entering inside the app ID, it will be pure pattern based matching. pattern based, signature based matching. And for that, this particular chip will be used at hardware level. And prior to 9.0 or till 9, at software level, these two application or these two algorithms will be used. And after 9.1, P-scan will be used at software level. At chip level, this chip will be used, and at software level, this particular algorithm will be used to do a pattern-based match. So once you have done the processing of this HTTP packet at ingress level, flow lookup, fast path, and now you are entering inside the app ID. If the model which you have purchased from the Palo Alto is having this particular chip, so your app identification engine will forward that particular packet to this chip to perform the pattern matching so that your DP CPU can be made free and made available for other tasks, because this pattern matching takes huge time, and it is very CPU cycle intensive process. So that's why we have these ASICs. I'm not sure whether you are aware of these ASICs or not. These ASICs are dedicated chips designed to perform a certain task very well. In recently, you must have heard of Bitcoin mining. People were doing the Bitcoin mining. You can do the Bitcoin mining from your laptop as well, but you will not be able to generate a full Bitcoin even if you run your laptop completely 24/7 throughout the years. Because your laptop is not designed to perform the hash on the ledger transactions, right? So we have the dedicated Bitcoin mining machines which are generating the hash values. They are using these machines. They are having these dedicated ASICs to calculate the hash and authenticate the ledger inside my blockchain journey. Okay, so this is what we do inside our Ocelot or Jaguar chips in Firewall. If you have this chip, then only it will be used. If you don't have this chip, let's take an example of virtual machine where you don't have these chips, right? So at software level, this pattern matching will be performed and your CPU will be doing it. So if I will compare the VM machine performance as compared to hardware box, there will be a difference. Until unless you have allocated more CPU, more resources to your virtual machine. Okay. So now when we will do the app identification, it will enter inside the Ocelot or Jaguar. In lower series, we have Ocelot chip. In higher series, we have the Jaguar chip. Okay. Now inside your app identification, first thing is like override. Check your override policy. If you want to save your CPU cycles, if you want to save your processing time, applications like DNS, ping, these are very small applications, but their traffic volume is huge in any infrastructure. Now just imagine you have 5,000 users in your branch. How many DNS packets they must be generating? And if you're doing the identification of this particular application for every connection, then you can just imagine how much CPU you are wasting of your firewall. See, I'll tell you one very perfect example here. It
ट्रेस रूट
depends
भी
who
है
has
सर
designed.
ट्रेस
Sorry.
ट्रेस रूट भी है सर ये तो काफी
So I'll give you an example here. Take it anything. If your architect is good or well experienced guy, he will design a better solution for you, a solution with least day two problems, or you can say the in life support problems. If your architect is less experienced or lacking in skill set, or you can say architect or technical design authority, they are lacking in skill set, they will miss out these best practices. And if they are going to miss out these best practices, your support life will become hell. You must have seen in your day-to-day working environment that few customer accounts are very smooth. You're getting less number of tickets from there, and few customer accounts are like hell. You're getting 20 to 30 tickets per day. Because the integration of multiple services, the deployment of multiple services have been not done properly in those accounts. And that's why it is becoming difficult for support engineers to work on these particular tickets. And you must have seen sometimes you got the feedback that this is a design issue, right? So that's why.
Very true, sir. Very true, sir. I have experienced this in SBI cards actually. So it has happened for almost like 1 to 2 years. Then they have actually switched their data center, and after that, like there was a day like every morning there will be multiple issues, slowness will be there. But after the
Exactly.
migration, the issue has been resolved. It happened almost for 2 to 3 years with them. Every morning a
Exactly.
ticket or case will be opened.
So in that case, what happens, what your client is going to do? Your client will understand that this managed service provider, now managed service provider, who are they? BT, Accenture, HCL.
Yep.
They don't have good resources. And in life team, or you can say the support team, will face all the escalations. Although the issue was at the very beginning, who has designed this architecture? That guy was not skilled enough to take care of such things and design a fail-proof solution. And the guys in support, they are doing like things are on record. I cannot say that word. So they are like they are cleaning their shit daily. Okay. So what we need to do is, if your client will see that once I have adopted this technology, let's say if I'll take example of Zscaler, if you will ask any normal company to implement Zscaler, your client will bang his head on the table and will say, yeah, it was my worst decision to go with this particular managed service provider because they were not having the good resources who were able to design my solution better. And that's why your certification comes into the picture. Why people ask for CCI certification? Why company check for that? If you are going to be my managed service provider, you need to ensure that you have at least 3 CCI L3 resources, 5 CCNP resources, because they are benchmarking these certifications as an standard that if a guy has done CCI, he must be knowledgeable. But that is not the case in India. In India, you know how these certifications are done. In fact, your CCI, right? If a guy is sitting in abroad, he is CCNA, he can beat the guy sitting in India if he is dual CCI, triple CCI, right? So that's why, companies, they check for the certifications. Do we have certified professionals? Yes, no, blah, blah, blah. But when we have next gen technologies, do we have CCI sort of thing there? If you talk about Zscaler, do we have something related to CCI in Zscaler? So if you will ask any CCI guy, do you know how to implement Zscaler in a best possible way? Answer will be no. They don't know. So you will become a good engineer when you will do more and more practice, when you will not do your job just to earn money, when you will do your job to gain knowledge out of it. Then you will become an engineer You need not anything at that point of time. You will be self-motivated enough to keep your track moving. You will yourself, you will do your research, you will start studying about the RFPs. What are the RFPs? Most of you might not be aware of this term even. What is the RFP, right? Who developed these protocols, how these are working, those things, then you will start your research, and then you will come to know that these certifications, these are just baseless things. You don't need them. They are just there for a company to get the order, or you can say to get the project. That's it. They are using your certification to get the projects, nothing else. It doesn't mean that if anyone is CCI, they will be smart enough to design any network or support any case. That cannot be the case. Okay, coming back to our original discussion. So application override. So it is the best practice to bypass these applications or any custom based applications. Now custom based application means the applications which are not well known. If you will check Applipedia, that is the application database of the firewall, Palo Alto firewall, there you will not find Ngcloudx application. No signatures are available because this is the new application, custom application. We are using it. Not every enterprise is using this. But if you will find YouTube, you will find, let's say Facebook, you will see their signatures available inside the database of the firewall, right? So now, if let's say I have created one rule, security rule with Ngcloudx application. If my firewall is not able to identify what the hell is Ngcloudx, how that particular security rule is going to take hit? So it will not take it. So if you want to create bypasses, such bypasses, then we use this application override policy. Okay. So if application override lookup, there is no match, then it will start the pattern-based application identification. It will start doing your pattern-based matching. Because each file, before this discussion, I have told you that each file has its unique fingerprint, or you can say signatures. That value will be matched across the database which we have. So basically, your firewall is going to have multiple databases. One database for application in signatures, one database for your threat, antivirus related signatures, right? One database for your URL categories, one database for your user to IP mapping, one database for your any other feature, let's say uh, uh, anti spyware, right? So you have multiple databases within your firewall. See, you must have done the troubleshooting till software level, I mean that configuration level. कि मोटा मोटा ऊपर से configuration देखा and that's it. But when you join tag, and if you are doing troubleshooting at hardware level and at OS level, then you should be aware of these things, these databases, because there will be time you need to repair these databases as well. I will cover these things in Cisco FTD. Reason being that in Palo Alto, they have blocked the root access for the normal people. Only TAC layer 3 engineers can get inside the root mode. Another thing is these boxes, be it Palo Alto, Cisco, Checkpoint, Fortinet, all these boxes, these are Linux boxes. Any networking device, it is a Linux based device. At base level, Linux is working, and on top of it, you can use, the base level, or you can say the kernel level. Your Linux is there, and on top of it, you can use any language, Python, any other scripting language to modify this Linux usage as per your requirement. So, in Palo Alto, we cannot get inside the root mode To see all these databases, to see all these config files, it is blocked. You need to get the uh, uh, token from the tag, and only tag layer 3 engineer gets the tier 3 engineer gets the token. They don't give to the service providers. But in Cisco FTD, we will see that how you can get inside the root mode, how you will be able to repair these databases if any corruption, any database has been corrupted, firewall is not working properly, how you can modify the config files, you can bounce the services. All these things we will cover inside this Cisco FTD training. Now
Sudo
this pattern,
users, sudo su, something like that they use.
sudo su, that is there to enter inside the root mode of Linux. Sudo means super user. So if you become the super user, you can do anything. So what happens? How your attack works? So what attacker will do? Attacker will first exploit the normal user, and then he will do the privilege escalation. Privilege escalation means this normal user will try to get the root level access. We call it privilege escalation. I'll give you an example. In your laptops, your administrator must have restricted you to install or uninstall the softwares. If you try to do it in your corporate laptop, it will ask you for the admin username and password, which you don't have. So whenever any machine gets compromised, let's say your normal user credentials have been compromised, hacker was able to log in into the machine by using your credentials. He won't be able to do anything until unless he has got the root access. So he will try for the privilege escalation attack. We'll cover all these things as well in upcoming sessions. Any doubt, anyone inside the app ID? So this pattern based application identification will try to identify the application from the app ID database we have inside the firewall. And if you have a match, then we will identify the application as Facebook, YouTube, whatever it is, and we will update the app ID cache. So here we are updating the app ID cache of slow path, so that if first time Rohan was accessing the Facebook, so we took all these processing steps. Next time when Sumit will visit the Facebook, right inside the slow path itself, I will be able to identify the application basis on destination IP and destination port, and the correct security rule will take hit. So I think Vikas, now you have got your answer, how things are working at granular level.
Oh, yes, sir. Yes, sir.
So whenever you do layer 7 inspection, you must have got this thing, in your audit reports as well. So whenever we do pen testing for any organization, so in audit reports, they mention that we were able to access the server despite it should be blocked in the firewall. We can see that TCP three-way handshake was done successfully. So answer will be, it will be done, because data packets will come right after the TCP three-way handshake, and then only firewall will be able to take the appropriate action. So for first time, it will be allowed. For next time, if firewall has blocked the IP inside the DOS block table, then the subsequent packets will be dropped. Clear? Any doubt, anyone? Now, Vikas, the thing which you were asking me, here is the answer to that. Security policy lookup with application. If I have identified the application, then I will do a security policy lookup again to identify a correct application, correct security rule for this. If there is a rule match, then I will check which security profile has been configured for this. If there is no rule match, then your packet will be dropped. Okay. Now I will check whether security profiles deep inspection has been enabled or not. If security profile, your antivirus, URL filtering, whatever IPS policies are there. If you have configured them, then we will flag the session for deep inspection, CTD, or you can call it SP3. That boss, this packet is available for deep inspection because security profiles have been implemented on this packet flow. Right after this, it will check, do we have any QoS policy? Yes, no. If no, then it will see what was your application. Is it SSL or SSH? Because if it is going to be SSL or SSH, it means it is encrypted and there is a need to decrypt the packet. If not, then it will simply go and enter inside the SP3 engine. If yes, then we will check, do we have decryption policy configured right here? Yes, no. If yes, do we have the exclusion cache available where we are excluding this particular application from the decryption because it will break the application flow? Yes, no. Okay. I will explain all these things in more detail. And then we will flag the session for proxy. That firewall is telling the proxy engine that boss, you need to do the forward proxy or inbound proxy on this particular session. But in our case, since we are making connection on port 80, it is not going to be the SSL or SSH application. So right from here, it will come inside this checkbox, which says CTD flags or layer 7 inspection enabled. And we have already flagged the session here because security profiles were enabled on the security rule. So then it will enter inside your SP3 engine. That is your single pass processing engine, where we will do the actual deep inspection. So that's it for now. We will have a dinner break and we'll connect after the dinner break.